Assalamu alaikum. Now I'm going to talk to you about surface active agent, or what's called surfactant. At first of all, we are going to talk about surface tension. Surface is the interface between liquid and air, or between solid and air. So here, between two immiscible liquids like water and oil, this interface is not called surface. Here, no surface. Here too, between water and any solid, there is no surface, only interface. But here we are talking about surface tension. In this case, we are meaning the interface between air and liquid. So what is tension? Tension is the opposite of stable. So tension means unstable. Here we have water molecules which is attracted together with attraction force, which is called cohesion. Cohesion is the attraction force between similar molecules, like between water molecules. Adhesion is the attraction force between different molecules, like between air and water. In this case, cohesion force is higher than adhesion force. As a result, the molecules of water at the surface is pulled down towards the bulk of the water in what's called net inward pull. That the molecules at the surface is pulled down towards the bulk. So the molecules at the surface is not stable, but it's pulled down, and another molecules is coming here instead. And if you don't know, surface tension is making this curve in your pipette or pipette. It's due to the surface tension that the water is trying to make the surface area exposed to air as least as most it can. So we have known enough about surface tension. Now we are going to talk about surfactant. Surfactant is formed of two parts, the hydrophilic part and the lipophilic part. If you don't know, lipophilic is mean lipid love, philic means love, lipo means lipid. So this hydrocarbonate chain is loving lipid, and it's lipid soluble. And in this head, it's water soluble because it's hydrophilic and it's solvent like. And here we have glucanion. This is sodium lauryl sulfate surface active agent. So in typical surfactant we have three parts: glucanion, and the hydrophilic part, and the lipophilic part. Now we are going to talk about how surfactant works. By adding surfactants to water, the hydrophilic part will be directed towards the water, and the lipophilic part will be directed towards the air. By adding surfactant molecules, it will be aggregated on the surface, which will result in decreasing surface tension. As we have known what is surface tension, so by adding more molecules of surface active agent, surface tension is reduced until we reach this point, which is called critical micelle concentration. At this point, any more added surface active agent will aggregate in the water and making what's called micelle. That happens after saturation of the surface. At this point, by adding more surfactant, the surface tension won't be affected anymore, because any added surface active agent will be aggregated as we see it. So what is micelle? Micelle is aggregation of surface active agent of about 50 monomers of surface active agent, and its size it's about 50 angstrom or 5 nanometer. So it's in the range of colloidal solution. As we have known, it's between 1 to 500 nanometers. So why surfactants are important? Surfactants are important because it's used in formation of suspensions, emulsions, and many other things. So if we have a lipophilic active ingredient and want to dissolve it in a liquid vehicle, what we must do? It's simple. We will just have to add surface active agent. This surface active agent will dissolve the lipophilic part, the lipophilic active ingredient, in the liquid vehicle, and suspension of the active ingredient will be formed. The mechanism on how it works: by adding the surface active agent and shaking it with the liquid and the insoluble lipophilic active ingredient. By shaking them well, the surface active agent will be aggregate and forming micelles, and that the active ingredient will be dissolved in the lipophilic part of the surface active agent, and the hydrophilic heads will be dissolved in the outer layer, in the outer phase. So what if we have the oil as dispersion medium? The lipophilic part will be dissolved in the outer phase. The lipophilic part will be dissolved in the outer phase, and the active ingredient will be dissolved in the polar heads. But here the active ingredient is hydrophilic in this case, but in this case was lipophilic. But here we have some kind of problem. These polar heads are bearing charges. So if we are using an anionic surface active agent, it must be repulsion must be present, because the negative charges will repulse it. There will be repulsion between each other. But what makes them held together is the gigenion. As we saw in the last example, sodium lauryl sulfate. Sodium is the gigenion. It will make them held together and no repulsion will occur. Thanks for listening.